stand on an isolated mountain peak, where the atmosphere vanishes into pure dark void. Our home galaxy is a flat rotating disk spanning 100,000 light-years. Over 100 billion stars orbit a central gravitational anchor in near-perfect harmony. 2.5 million light-years away, a massive neighbor orbits in the dark. The Andromeda Galaxy, Messier 31, contains nearly 1 trillion stars. It spans over 220,000 light-years across, double the size of our galaxy. Between us lies a vast ocean of intergalactic space, cold and empty. Yet, these two cosmic titans are locked in an inescapable gravitational pull. Andromeda is hurtling toward the Milky Way at 110 kilometers per second. That is roughly 400,000 kilometers every hour relative to our Sun. Despite this immense speed, the vast separation delays the impact for eons. Both belong to the local group, bound together by invisible dark matter. Enormous halos of dark matter extend far beyond their visible stellar disks. These dark matter halos act as massive gravitational anchors, pulling them together. The gaseous halos surrounding each galaxy stretch over 1 million light-years. Recent space observations show these outer halos have already begun touching. Ultraviolet instruments onboard space telescopes confirmed this invisible boundary. Hot, ionized gas is already compressing at the boundary between two worlds. The grand galactic dance has quietly commenced in the silent darkness. What fate awaits our planet during this cosmic encounter? Will individual stars smash into each other during the collision? Or will entire planetary systems be cast out into intergalactic space? To witness the transformation, we must fast forward through billions of years. Time accelerates, and the night sky prepares for an unprecedented spectacle. 2 billion years into the future, Andromeda grows dramatically in our sky. Its brilliant core and dust lanes become clearly visible to the naked eye. As the galaxies draw closer, mutual gravitational attraction accelerates them. Diffuse hydrogen gas between the galaxies is squeezed into high-density zones. Shockwaves ripple through interstellar gas clouds at millions of miles per hour. 3 billion years from now, the night sky is completely dominated by Andromeda. Spiral arms reach across the horizon, casting faint shadows on Earth. Gravitational tides begin warping the outer disk of the Milky Way. Stars at the edges are pulled out of their circular orbits. Long streams of stars begin forming stellar bridges between the two galaxies. Meanwhile, our Sun is gradually evolving into a hotter, brighter star. Core fusion rates increase as helium accumulates at the solar center. Increased solar radiation has driven runaway evaporation of Earth's oceans. Earth is now a dry desert world, but its orbit remains stable. Why do stars rarely collide directly during galactic mergers? The distance between stars is immense compared to their physical diameters. If stars were the size of oranges, they would be separated by thousands of miles. Stellar collisions are statistically almost non-existent during the event. Galaxies interact primarily through gravitational fields, not physical impacts. Relative velocity of approach reaches nearly 400 kilometers per second. Gravitational torque begins to deform both galactic spirals permanently. The edge of Andromeda's disk makes its initial pass through our galaxy's halo. Night sky from Earth features 2 giant glowing galactic cores. Interstellar gas clouds clash, setting the stage for galactic starbursts. The moment of first close pass is now at hand. 3.8 billion years from now, the galactic centers make their first close approach. They slice through each other's outer disks without central collision. Violent tidal forces pull vast streams of stars out into deep space. Tidal tails extend over hundreds of thousands of light-years. Compressed molecular gas triggers the violent birth of millions of stars. Massive star clusters form rapidly throughout colliding gas streams. Ultra-luminous blue giant stars illuminate the distorted galactic bodies. From Earth, the night sky is illuminated by thousands of new bright nebulae. These short-lived massive stars burn through their fuel in a few million years. Thousands of supernova explosions detonate across the merging system. Supernova shockwaves enrich interstellar clouds with heavy elements. Gravitational friction acts as a massive energy drain on both galaxy cores. Their relative velocity slows, trapping them in a decaying binary orbit. The Sun's path around the Milky Way core is heavily altered by gravitational pull. There is a 12% probability our solar system will be flung into the tidal tail. It could be carried millions of light-years away from the galactic center. Despite this relocation, gravitational bonds between planets remain undisturbed. Planets continue orbiting the Sun safely in their local space. If flung out, the sky from Earth would show two merging galaxies in the distance. The galactic cores reach maximum separation after their first flyby. Giant loops of stars wrap around both galaxies like luminous cosmic ribbons. The pristine spiral structures of both galaxies are destroyed forever. They are now classified as a pair of strongly interacting irregular galaxies. Dark dust lanes are torn apart and distributed throughout interstellar space. Gravity stops their separation and begins pulling them together for a second pass. 4.5 billion years from now, the two cores plunge back inward. This second passage is far more violent and destructive than the first. Billions of stars are displaced into a vast, shared stellar halo. Gas clouds lose orbital angular momentum and crash into central regions. Vast quantities of gas channel directly toward the central supermassive black holes. Sagittarius A** at the center of the Milky Way begins feeding voraciously. Andromeda's supermassive black hole, 100 million times more massive than the Sun, activates. Both supermassive black holes transform into blazing active galactic nuclei. Relativistic jets of plasma launch from their magnetic poles into space. These jets heat surrounding gas, driving powerful galactic-scale outflows. Intense X-ray and gamma radiation sweep across the central regions. The combined brilliance of the two active nuclei rivals the light of all stars combined. The two supermassive black holes orbit each other in a binary dance. Dynamical friction with surrounding stars draws them progressively closer. Stars passing near the binary black hole are violently slingshot away. The core regions are cleared of stars through gravitational scattering. From an internal planet's view, night sky features a dazzling double-core glow. Old familiar constellations are completely gone, replaced by a dense stellar sea. Gas reserves across both galaxies are rapidly consumed by star formation. The starburst phase reaches its climax, depleting available raw material. The galactic disks have now merged into a single irregular ellipsoid mass. The distance between the twin supermassive black holes drops to a fraction of a light-year. They begin emitting powerful gravitational waves into spacetime. The final merger of the black holes is now seconds away in cosmic time. 5 billion years into the future, the twin supermassive black holes collide. Their event horizons merge into a single massive black hole exceeding 100 million solar masses. The gravitational recoil kick shifts the new black hole slightly from the core. Residual gas around the core is blown away by the final energy surge. Without cold gas, all star formation in the merged galaxy permanently ceases. The galaxy begins its transition into a red and dead elliptical galaxy. Meanwhile, our Sun has exhausted hydrogen fuel in its core. The Sun expands rapidly into a majestic red giant star. Its outer atmosphere expands past the orbits of Mercury and Venus. Both inner planets are vaporized and absorbed into the solar convective envelope. Earth's surface is completely scorched into an ocean of glowing magma. The atmosphere is stripped away into space by extreme solar radiation. Our home planet becomes a glowing, lifeless, molten rock. Eventually, the red giant Sun ejects its outer layers into space, creating a colorful, short-lived planetary nebula in deep space. A colossal burst of gravitational wave energy ripples across the universe. At its center remains a superdense, cooling white dwarf star. The charred remnant of Earth continues orbiting this dying stellar core. Across the merged galaxy, individual stellar orbits begin settling down. Gravitational interactions smooth out all remaining irregularities. The original spiral disk shape is gone completely, replaced by a smooth triaxial giant elliptical galaxy. Out of two distinct spiral worlds, a giant cosmic titan is born. Astronomers name this future-merged system Milky Way. A new long-term equilibrium has been established in our cosmic home. 6 billion years from now, Milkomeda reaches full structural maturity. It contains over 1 trillion ancient, low-mass stars. Stars move in complex three-dimensional orbits around the center, creating a featureless, football-shaped swarm of light across space. Star formation has stopped completely due to lack of cold gas. Long-lived red dwarf stars dominate the stellar population of Milkomeda. These red dwarfs will burn fuel steadily for trillions of years. Later, the triangulum galaxy M33 is also absorbed into Milkomeda, adding its mass to the outer halo of the giant elliptical galaxy. Meanwhile, dark energy continues accelerating the expansion of the universe. Distant galaxy clusters are pushed beyond the cosmic horizon. Trillions of years from now, Milkomeda will be alone in the observable universe. Future observers living inside would see no other galaxies in the sky. They would conclude their single galaxy is the entirety of the universe. The memory of the original Milky Way and Andromeda will fade into history. Yet every star and particle in Milkomeda carries their shared legacy. Galactic collisions are not cosmic disasters of destruction. They are the fundamental mechanism of cosmic growth and evolution, transforming small spiral disks into massive, long-lived galactic titans. Our Sun's white dwarf remnant rests quietly in the outer realm of Milky Way, a silent testament to the eternal cycle of galactic birth and rebirth. As you look up at tonight's sky, Andromeda is approaching us right now. Traveling through the dark space void at 110 kilometers every single second. An inevitable cosmic appointment written in the fundamental laws of gravity. A majestic collision that will forever reshape our corner of the cosmos. Thank you for watching. The mysteries of the universe await us.